You're watching TelecomTV, and joining me now is Martin Taylor, CTO of Metaswitch. Martin, we spoke earlier about the cloud-native telco and what cloud-native means for telcos, but if we can look at some of the detail now, some of the key features of a cloud-native application architecture and what the cloud-native ecosystem comprises. To start with, though, when we talk about cloud-native technologies, what are we talking about and what do they actually mean for telcos?
Well, cloud-native technologies, I think really the best way to describe this is it's the current set of best practices that you see in the web scale world. And one of the problems here is it's a little bit of a moving target. So what looked like cloud-native in 2013 is not quite how it looks now. Things have moved on a bit. But what we're talking about here is a set of best practices that allow one to build very scalable, very resilient, very agile systems in the cloud. They tend to be very portable, and they tend to be highly automated in their operations. That's kind of what they look like from the point of view of characteristics from the outside.
So if we can identify some of the key features of a cloud-native application architecture, and I guess perhaps we should start with containers. Containers is very often closely associated with cloud-native. What are containers, and how does it relate to cloud-native?
Well, containers is a way of packaging software so that multiple workloads can run on a single host. So we think of it as kind of virtualization 2.0. Where virtualization 1.0 was the virtual machine. Virtual machines make sense when you've got lots of different operating systems, but they don't really make sense when everything's written to run on Linux, and that's really where containers come in. So it's a lightweight virtualization technique. That's really all that it is. Now, it's kind of indispensable to cloud native these days, but it's so. To be cloud native, you need to be in containers, but just because you're in containers doesn't mean you're cloud native, because you can take a legacy, monolithic, multi-million line of code software appliance, package it in a container, and run it on a cloud. That does not make it a cloud native application.
And orchestrating this huge fleet of containers is, I guess the default now is Kubernetes.
Absolutely right, yes. I mean, when containers first emerged, there were 2 or 3 other contenders, but I think Kubernetes has emerged. Really, everybody else has fallen by the wayside, so that's really where all the action is.
And leading on from the containers, this one leads on to microservices.
Yeah, so microservices are another sort of key feature, if you like, of cloud native. I mean, the Cloud Native Compute Foundation, always its kind of basic criteria are it should be containerized, it should be microservices based, and it should be dynamically orchestrated. Those are really the kind of 3 criteria. But you can expand on those. There's a whole bunch of other characteristics. And if you look at the CNCF website, there's some very good material there. For example, they talk about a cloud native trail map, which talks about the journey to cloud native, and obviously includes things like Kubernetes, projects like Helm, which is a way of templating a complex Kubernetes-based deployment, and then instrumentation systems like Prometheus and FluentD and Grafana, which allow you to apply telemetry and monitor and get alerts and so on, key performance indicators and so on out of your system. There's a whole bunch of stuff on that website which I think is absolutely should be embraced by anyone that's building a cloud-native network function.
There's a whole raft of technologies then, and I guess a whole ecosystem around it.
Absolutely. I mean, that's one of the great things about cloud native. There's a ton of stuff there that traditionally you'd have had to write all this stuff yourself, and not having to do that is great. But there is always a temptation on the part of people that write software. They take the not invented here approach, or they say, well, you know what, this little piece of software, might be all right for most people in the enterprise space, but it doesn't really work for telcos, and so we need to write our own. That way leads to a lot of misery, because it's so much better to stick with mainstream open source projects, because you benefit then from all the community work that goes into evolving those over time.
Another important concept in cloud native is stateless processing. Mm-hmm. What does that actually mean?
So what that implies, in most network functions, there's a lot of, you kind of sort of transaction processing. In the control plane of network functions, you've got protocol messages coming in, you've got work being done on those messages, decisions being taken, new messages being generated and sent on. The idea with statelessness is that you do that in a processing element that doesn't have any memory of what happened after the transaction took place. Instead, any change in the underlying state of the system, be it registration state or session state or whatever it might be, is stored in a back-end store. And while that might sound like a kind of sort of complicated and arcane way of doing things, it has huge benefits in terms of scalability and resilience and resource effectiveness, because it means that you can get a resilient system without having to double everything up, which is the traditional way of telco fault tolerance.
Now, these aspects and features we've talked about, and obviously there's more, can these techniques be applied to a telco's network functions?
Absolutely, yes. I mean, we were probably the first to prove this. This is in relation to IMS back in 2013 when we released Project Clearwater. So that was probably the first example of a software vendor actually taking the web scale principles, kind of cloud native architectural patterns, and attempting to apply them to a traditional telco network function, in this case IMS, where instead of, in the web scale world, people think in terms of HTTP-based transactions and interacting with the web. In the telco world, obviously, we're talking about telco protocols like SIP. So in effect, what we were proving was that you could take something like SIP and apply statelessness and microservices and scale out architectures and so on to that protocol. And I think the world has kind of learned from that, and now we're seeing proliferation of that to other kinds of things. And of course, the 5G packet core architecture is very much designed with that kind of approach in mind.
Service-based architecture.
Absolutely. Service-based and also somewhat microservices oriented, and also envisaging statelessness. Now, it doesn't mandate that, but it certainly provides a foundation for and describes state stores as distinct from functions like the access management function, session management function, and so on.
So we can apply cloud native to control plane and data plane functions?
You can. The thing about data planes is that they are inherently stateful. There's a lot of stuff that you have to have in memory when you're processing packets, or even in cache. Now, just because something's stateful doesn't mean you can't implement it in cloud native form. I mean, there are lots and lots of state storage systems, like Cassandra, for example, which are well known in the cloud native world, which are stateful because they store information, right? So, when you're looking at a cloud native data plane, what you're aiming for is something that is comprises a variable number of packet processing engines, which can scale on demand, across which load is distributed, that has a little bit of surplus capacity so that you can have an N+K resilience, that can support in-service software upgrade by doing a rolling upgrade of packet processing engines. Those are the cloud-native characteristics you're looking to achieve. Now, these engines themselves are stateful, so you have to figure out, well, how are we going to distribute the overall system state across our population of engines? How are we going to back it up? And how are we going to ensure that when a packet processing engine fails, the sessions that were there get moved somewhere else where we can pick up where they left off? All of those problems are soluble, and in fact, we've demonstrated that with our Fusion Core UPF, which is part of our overall Fusion Core 5G product.
So in an ideal world for a telco, all their network functions would be truly cloud native, packaged into containers, orchestrated by Kubernetes, nice and simple, nice and clear. But the reality is a little bit different. We're dealing with a lot of legacy infrastructure.
Absolutely. And so the challenge in moving to 5G is that the bulk of the 5G service market, if you like, is enhanced mobile broadband. And that's very much a continuation of the services that existed in the LTE space. So there's a lot of legacy capability there, and I think it'll be quite a long time before all of that legacy functionality is embodied in a truly cloud-native solution. So I think we see the entry point for cloud-native in 5G as really being around the new use cases that 5G enables, and we're talking about edge computing as a key area here. And of course, edge computing embraces a whole bunch of use cases: industrial robotic control, AR, VR applications, all sorts of IoT capabilities. These are services where a lot of the legacy stuff around mobile broadband just doesn't apply. We don't need to detect whether a smartphone user is tethered their laptop. It's the kind of thing you have to do in mobile broadband. And so there's a much lower barrier, if you like, to delivering a functionally useful solution in these new use cases than there is in mobile broadband. So I think to us that's the obvious entry point, if you like, for truly cloud-native solutions in 5G.
So finally, if we look at cloud-native network functions, if we look at cutting through the hype, going past these sort of vague definitions of cloud-native and loose definitions, the move from a physical network function to a virtual network function, it's quite clear, you're virtualizing a physical aspect. The move then from a VNF to a CNF doesn't seem to be quite as obvious or quite as easy as that first one.
For sure. I mean, what quite a lot of vendors did in the first phase was really just extract the software that they had running on their traditional chassis-based systems and package it in virtual machines so it could run on a hypervisor. And in some cases, they even went as far as writing an emulation layer that made the virtual machine look like their traditional hardware, which is horribly inefficient. I mean, it gets you there quickly, but that's one of the reasons why telcos have been very disappointed with the whole NFV thing, because what they've seen is something that's inefficient and clunky and actually uses a lot more hardware than they would expect. So that's kind of taking the shortcut approach, if you like, and as I say, it really doesn't move the ball forward at all as far as operations automation is concerned. All the other benefits that cloud native will bring. But as I say, the big challenge here is because cloud-native architectures look so fundamentally different from legacy appliance-based software architectures, you really have to start with a clean sheet of paper. And that requires huge investment, massive amount of commitment, and it takes time. It just takes time to build a minimally viable product that meets, was typically a pretty high bar. I mean, telcos have a lot of complicated requirements around, all sorts of aspects of network functionality, and they have to be met before you have something that's deployable.
So is the industry in a slight danger of looking at this from the wrong direction? It's looking at it from an evolution of what they have, VNFs, rather than saying, what is it these network functions are trying to achieve, and then look backwards to how to...
I think that's a very good way of putting it, yes. Yeah, I mean, I think it makes sense to say, okay, what's the ideal vision of what this thing looks like? And what would the web scale solution be? I mean, that's how we came up with Project Clearwater. We didn't say we're going to build a virtualized IMS. We said, what would be the ideal way of offering a SIP-based calling service in the cloud? And it turned out that, well, you just apply all these web scale architectural patterns, and you end up with something that is phenomenally scalable, resilient, efficient, and so on. So you've really got to go back to first principles, and that's always a tough thing to do when you've got all this legacy requirements and stuff that you've got to address as well.
Well, Martin, thanks again for joining us on Telecom TV and sharing your insights. Thank you.
Thank you.